Hello guys, in this video I am going to show you how you can locally install this Instruct IR on your local system with only one GPU. You can even try it out on CPU as I will be doing in this video. Just to give you a quick overview of as what exactly Instruct IR is, if you are looking to do some image editing, especially restoring the image with the help of generative AI, then Instruct IR is one of the best models out there. Instruct IR takes as input an image and a human written instruction for how to improve that image. The single neural model performs all in one image restoration. Instruct IR achieves state of the art results on several restoration tasks, including image denoising, deraining, deblurring, dehazing, and also low light image enhancement. They have used the datasets like BST100, BST68, Urban 100, Rain 100, and a lot of others in order to train this model. So let's get started. I'll be using my Ubuntu system for this. So let me log in there. And as you can see on your screen, I'm using Ubuntu 22.04. Let me clear my screen. First step we need to do is to git clone this GitHub repo. So let me grab the GitHub repo URL. In order to grab that URL, all you need to do is to go to that GitHub repo and then go up a little, click on this green button, grab it from here. Okay, let me show you where I am at. Okay, let me go there. So this is the one. So go up, click on this green button and grab from here. Now once that's done, go back to your Ubuntu system or whatever Linux you are using, and here you can simply do git clone and paste that URL, press enter, and that should be cloned to your local system. I already have done it, so let me go to that clone repo, and if I do ls-ltr, this is the whole stuff which I have already there. So that is all you needed to do. Now as a prerequisite, all you need to do is to install pip install pillow if you don't have it, and as I already have it, so I'm not going to reinstall it. Now let me fire up my Python interpreter. So this is my Python interpreter. First let's import some of the prerequisites which are required. So as you can see, I'm importing OS, pillow, numpy, and lot of other things from this Instruct IR. Let's press enter, that's done. As a next step, let's specify the seed here, and we are just giving a random value of 42 here, and then we are calling this seed everything. Now this seed thing, it is just simply a random number which initialize the model weights and splits the data set into training and validation set, and also this is also used for selecting the data for mini batches, but here it is mainly to initialize the model weights. And this seed underscore everything, this function is to set the seed for all possible sources of randomness to ensure that the experiments are reproducible. Okay, so now we know what the seed is, and now let's further initialize our model. So what we are doing here is we are specifying this config for the model. This is just evaluation one, which is in this GitHub repo, which we have just cloned. We are specifying our Instruct IR model here. PT means it is a PyTorch one, and then we have just to load the configuration and changing the dictionary to the namespace. That's done. After model initializing, now let's create the model. Now if you look here, what we are doing is we are using this Instruct IR to create the model, and we are passing it various parameters. So if you look at these parameters, there are a lot of them. For example, we are passing the input channels, which specifies the number of input channel for the model, and this refers to the number of color channels, for example 3 for RGB images and so on and so forth. Then we have something width dot cft dot model width. It is the width of the model architecture or the dimensionality of the specific layer. And then similarly we have this enc blks, which specifies the number of blocks or layers in the encoder part of the model. And then we have this middle bulk num, which is a number of blocks or layers in the middle section of the model, which refers to a bottleneck or intermediate processing steps. Then we have this DEC case, which specifies the number of blocks or layers in the decoder part of the model. So DEC for decoder, and TXTDEM is specifies the dimensionality of the text features if model is able to decipher that. Okay, now let me run it. So it has loaded the model or created the instance of the model. And now let's load the model by using the assertion of Python. There you go, it's done. And now let's load the model. So if you look at this command, what is happening here is that we are using this quite common PyTorch library for loading pre-trained model weights into a model architecture. So in this one, we are using this load state dictionary one, and these are the parameters. The first one is torch.load model name. What this one is doing is that this function, the whole one with CPU, this whole function loads the model weights from a file specified by model name, which we already have done above. Then the map location argument specifies where to load the model. In this case, we are using CPU. What it means is that the model weights will be loaded into the CPU's memory instead of GPU. And the problem here is that if you don't have a GPU, then this doesn't bar you from using it. That's the beauty of it. Okay, and then strict is equal to true means that once some model weights are loaded into memory, then this ensures that the keys of the state of dictionary in the loaded model and the current model match exactly. Okay, let's run it. So keys are matched. Happy days. And now let's just get the number of trainable parameters. So that is done. Okay, so that's done. Now let's initialize the language model class. Let me go beta down, or let me clear the screen to make it more visible. Now, if you look at what is happening here is we are simply okay, so this is going to, okay, that is done. So you can see that we are primarily loading or initializing the model, and especially we are setting this LM head here, and this LM head is primarily a neural network layer that maps the output of the language model to specific classes or tasks. The dimension for embedding and the number of classes are also specified here. Okay, so that part is done. Now we need to specify our image processing, and for that let's define a function which is going to do the image processing. So let me paste it here. I'm going to simply clear the screen just to make it more visible. So this is a function I'm defining. Now if you look at this function, it is pretty simple. It is just accepting an image and text prompt as an example, and then from there it is using the model to process the image, and from there it is returning us the result. Okay, so let me enter here. So that is also done. One thing I wanted to point out, this X hat one. So basically the image tensor Y and text embeddings are fed into the main model here. So a model is taking both visual and textual information into account to generate the output. That is the purpose of this line. So that is done here. Now, so this is all we need to do, and from here now we can talk with our image. So let me clear the screen. First, what we need to do is to make sure that we have image in our system. So let me load the image and also show you the original image, and then I will give that image and text prompt to the model and show you the resultant image. So this is the original image which I'm going to use, and I will load this image in my model, and then I will ask it to retouch it because it is a bit dull. So I just want to retouch it as a professional look. Okay, so let's go back to our Ubuntu. Let me specify the image. So this is the image which I already have uploaded, and the prompt I'm using it that retouch the picture as a professional photographer, please. So you can change it as you like. Now let me load the image and restore the image. So it is restoring the image as per my own prompt, and let's save it to my local system. So I'm going in order to save it, the command which you can use it is, let me also put it in the resultant directory. So I'm just saying images and results and this, and just call it result.png, press enter, and it has saved it. Let me pull it out and show it in the browser. So this is the original image, and when it was retouched, this is the new image. Look at the quality of it. So let me do it again. This is the old image, and look at the glow. So this is the new image after the retouch by this Instruct IR. How cool is that? Now let me remove these raindrops from this image with the help of this model. And what I'll do, I'll just pass this image and I will ask in a text prompt from the image to remove these raindrops, and then we will display it again. Let's go back to our Ubuntu system. Now if you notice, we have already saved the new image in this restored image, right? So let's just specify another prompt. Okay, sorry. So let me specify, maybe I'll just use another variable in order to specify it. So I'm just saying that, let me paste it here to make it easy. So I'm saying that I love this photo. Could you remove the raindrops? Please keep the content intact. So it's just a variable prompt one. Now let's get another one, another variable, and call this process image function. Now just pass this image, the restored image here, and from there I will also pass my prompt one, which is a new prompt, and then press enter. And once that's done, that is done. Cool. Now let's save it. So I'm just saving this result one, and then I will just save it in my local system. Maybe I will just call it images result. Maybe I'll just call this result2.png, and then simply close. That's it. Okay, so let me open it in the browser and show you. So if you remember, this was our new image which was touched up, and then we asked it to remove the raindrops, and this is our removed raindrops image. How cool is that? And if I take you back, this is our original image which was dull. We retouched it and then we removed the raindrops. How cool is that? So in this example, I'm going to give it my own old photo and I'm going to ask it to retouch it. And you can see it is a bit dull. So let's see if it is able to retouch the photos in the human form. Let's go back to my Ubuntu screen. So you can see that I'm loading my photo here and then passing the prompt to the model that can you make it look stunning like a professional photo, and then it is restoring the image. So let's wait for it to come back. Let's save it. That's done. Now let's go back to see if it was able to do it or not. So this is my old photo and this is my new one. So it has just made it more glow with the proper lighting and stuff. There you go. So amazing stuff. I hope that you enjoyed it. Let me know how you go. I think I'm really very impressed by this model. And in the previous video, I also showed you how you can use it on Google Colab. If you don't have access to a Linux system, you can even use it in Windows by using Windows subsystem for Linux. I'll drop the link to this GitHub repo in video's description. Let me know how you go. Please share your thoughts in the comments. If you like the content, please consider subscribing to the channel. And if you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.